Welcome in for math. Right now we're watching the lesson for 11.7, problem solving area of rectangles. So we're using strategies to find patterns to solve area in problems. We're going to go ahead and lock the problem first, and then I'm going to be answering the questions in the yellow box to help me frame my thinking for today. Mr. Coy wants to build storage buildings, so he drew plans for the buildings. He wants to know how the areas of the buildings are related. How does the area change from the area of building A to the area of building B? And how does the area change from the area of building C to the area of building D? We're going to use the graphic organizer below to help us solve the problem. So what do I need to find? The question is asking me to find how the areas will change from A to B and from C to D to look for a pattern. So I'm going to need to use some information from the word problem. I need to use the length and the width of each building to find its area. And I will use that information by recording the areas in the table below with the purple top. Then I will look for a pattern to see how the areas change. So first, let's go ahead and look at the table. It tells me that building A has a length of 3 feet. And if I look over at the top for building A, it tells me that it has a width of 4 feet. So I'm going to go ahead and just put that in there. 4 feet is my width for building A. Down. Great. So remember, I can find the area by multiplying 3 times 4. 3 times 4, I already figured it out, is 12. So I know that the area for this is 12 square feet. Now let's go ahead and look at building B. Building B has a length also of 3 feet. They have that in common, but the width is different. The width on building B is 8 feet. What do you notice about that compared to building A? What's different between building A and building B already? If you said that building B's width is double or 2 times the amount of building A, you're absolutely correct. So that means we're going to go ahead and find the area. 3 times 8 equals 24 square feet. Okay, so already let's go ahead and talk about how that changed. Well, if we know our multiplication and division facts, which most of you do, we know that 12 is half of 24, or that 24 is double 12. So if you had multiplied 12 times 2, you would have gotten 24. We can see that because look, the width changed double. 4 times 2 would get you 8. So therefore, that would affect the total area. Let's go look at building C, see if that pattern continues. The length in building C is 6 feet. That's that long side. So I'm going to go ahead and put 6 feet in for my length. What do you notice about the length of building D? Yeah, it's the same. It is also 6 feet. No pattern there. It's just the same. Kind of like how the length was the same in the first 2 sets. Let's go ahead and take a look at the width. The width is already filled in. The width of building C is 4 feet, and the width of building D is 8 feet. Same pattern again. 4 times 2 would equal 8, meaning building D is double the size, double the width of building C. Let's see if that pans out to be true. 6 times 4 is 24 square feet. I'm going to go ahead and plop that in. I wonder, do you think that the area will be double of 24? If so, what would that be? Well, let's see. 6 times 8 is 48 square feet. That is double of 24. 24 times 2 would be 48. It's double. So therefore, the pattern that we saw here is that the widths were doubled and therefore the areas were doubled. Let's see if we can keep finding patterns. Okay, so we're back with Mr. Coy. He's building more storage buildings. He wants to know how the areas of the buildings are related. And how does the area change from the area of building E to the area of building F? And how does the area change from the area of building G to the area of building H? We're going to use this same graphic organizer to help us organize. So I need to fill in all of the lengths and the widths for these different buildings. The length is the long side, so that's 5 feet on building E. Oh, I do not like this pencil. I'm going to switch it out really quick. 5 feet. And the width is 8 feet. I'm going to go ahead and do my multiplying right now. Oh my goodness, that's a big label. 5 times 4 is 40 feet. Labels are very important in measurement. Building F, the length is 5 feet. The width is 4 feet. 5 times 4 is 20 feet. What would you say about these two areas already? What conclusions can you make? Great conclusions. Yes, 20 is half of 40. If you multiply 20 times 2, it would get you to 40 feet. So we're seeing the same pattern. I also noticed that the widths were the same way. 4 times 2 equals 8. And therefore, when we have a double of width, the area will be then double of each other as well. Let's see if that pattern follows suit with buildings G and H. Building G's length is 10 feet. There it is, 10 feet. And the width is 8 feet. Ooh, I love tens. 10 times 8 is 80 feet. That's the area of building G. Building H, the length is 10 feet. And the width is 4 feet. 10 times 4 is 40. What conclusions can you make about the areas between the two buildings? How does the area change from the area of building G to the area of building H? The area changes from building G because it is double the size of building H. Building H's area is only half the size of building G. We know that because if we had 40 times 2, that would get us 80, and that means that this is double than that. It is double 40. Keep looking out for patterns today, you guys, because it will really help us understand how area can change from building, from figure, and lots of different shapes. Let your teachers know if you have any questions.